Hello student, myself Mr.S.Suresh Kannan, working as assistant professor in ECE department, PSN College of Engineering and Technology. So today we are going to discuss about microwave system. So it is based on the high frequency applications we are using for microwave devices. Initially, we are going to discuss the various topics. Initially, introduction, electromagnetic frequency spectrum, frequency band and its applications, US new military microwave bands, IEEE microwave frequency bands, diagram of microwave system, advantages, disadvantages, and applications and the components of microwave systems. So these are the topics we will be discussed on today. So introduction, microwaves are electromagnetic waves. That means it is a high frequency wave which have the wavelength ranging from 1 centimeter to 1 millimeter. The corresponding frequency range is 1 gigahertz, that is 10 power 9 hertz to 300 gigahertz, that is 3 into 10 power 11 hertz. This means the microwave frequencies are up to infrared and visible light regions. So this is the range of frequency range of microwave signal, and it's the wavelength of microwave signal. So the microwave frequencies span the following three major bands at the highest end of the RF spectrum. First one, ultra high frequency, that is called as UHF. The range is 0.3 to 3 gigahertz. Second one is the super high frequency, that is SHF. The range is from 3 to 30 gigahertz. And the extra high frequency, that is called EHF, which is the range is 30 to 300 gigahertz. Most of the applications of microwave technologies make use of frequencies 1 to 40 gigahertz range. So this is the electromagnetic frequency spectrum, which having the different waves from ELF, means extremely low frequency, the range from 30 Hz to 300 Hz, and SLB means it is range from 300 to 3 kilohertz, and BLF, it is very low frequency, the range is 3 kilohertz to 30 kilohertz, and the low frequency is represented as LF, the range is 30 kilohertz to 300 kilohertz. Then medium frequency, the range is 300 kilohertz to 3 megahertz. Then the high frequency range is 3 megahertz to 30 megahertz. Then very high frequency, the range between 30 megahertz to 300 megahertz. In ultra high frequency range, 300 megahertz to 3 gigahertz. And here we are using the microwave frequency from 3 gigahertz to 300 gigahertz. It is called as super high frequency, and the extra high frequency 30 gigahertz. The infrared and the light and the X-rays, gamma rays and the cosmic rays. So these all are the ranges from 300 gigahertz to 430 terahertz and 430 to 1000 terahertz, and 10 power 18 hertz and 10 power 20 hertz, 10 power 28 hertz respectively for the electromagnetic frequency spectrum. And the frequency band and its applications, as we know that the various frequencies 30 to 300 hertz, it is a extremely low frequency, that is called 1, the wavelength is 10 to 1 millimeter. It is used in the communication purpose in the submarine systems, and the range of 3 to 30 kilohertz, the frequency is very low frequency, the wavelength is 100 to 10 kilometer, and it is used in long distance point to point communication, navigation and sonar, that is called as sound navigation and ranging applications. And the frequency band 30 to 300 kilohertz, it is called as low frequency, and the wavelength is 10 to 1 kilometer, and it is used in point-to-point marine communication, navigation systems. And the frequency band 300 to 3000 kilohertz. The medium frequency is called as medium frequency, and it is based on the wavelength is 1000 to 100 meter, and it is used in AM broadcasting, marine communication, coast gold communication. The frequency band 3 to 30 megahertz, it is high frequency, and the wavelength of the high frequency is 100 to 10 millimeter, and it is used in telephone, telegraphy, facsimile, that is called the fax, and the shortwave international communication purpose. And the frequency range 30 to 300 megahertz, it is called as very high frequency. The wavelength of the very high frequency is 10 to 1 meter, and it is usually in television, FM broadcast, air traffic system. And the frequency band, it will be 300 to 3000 megahertz. It is called as ultra high frequency, and the wavelength is 100 to 10 centimeter. It is usually in television, satellite communication, and the radar. Radar means it is a radio detection and ranging. And the frequency range 3 to 30 gigahertz, it is called as super high frequency, that is 10 to 1 centimeter. It is usually in radar and microwave and space communication, satellite communications. The range of frequency band from 30 to 300 gigahertz, it is called extremely high frequency. It is the wavelength is 10 to 1 millimeter, and it is usually in radar and microwave, space communication, satellite communications. So the US new military microwave band are represented as the frequency range, and 100 to 250 megahertz is microwave band designation is called as A. Similarly, 250 to 500 is called as B. 0.1 gigahertz to 1 gigahertz is called as C band. 1 to 2 gigahertz is D band. 2 to 3 gigahertz is E band. 3 to 4 gigahertz is F band. 4 to 6 gigahertz is G band. 6 to 8 gigahertz H band. 8 to 10 is called as I band. 10 to 20 gigahertz J band. 20 to 40 gigahertz is called K band. 40 to 60 gigahertz is called L band. 60 to 100 gigahertz is called M band for military microwave bands. And IEEE microwave frequency bands will be divided into different categories. From 3 to 30 megahertz is called high frequency. 30 to 300 megahertz is called very high frequency. 0.3 to 1 gigahertz is called ultra high frequency. 1 to 2 gigahertz is equal to L band frequencies. 2 to 4 gigahertz is called S band frequencies. 4 to 8 gigahertz C band frequency. 8 to 12 gigahertz is called X band frequencies. 12 to 18 gigahertz is equal to KU band frequencies, and 18 to 27 gigahertz is called K band. 27 to 40 gigahertz is called KA band. 40 to 300 gigahertz is called millimeter, and greater than 300 gigahertz is called a sub-millimeter band. In the microwave system, normally it consists of a transmitter subsystem including a microwave oscillator, waveguides, and transmitting antennas, and a receiving subsystem that is include a receiving antenna, waveguides, microwave amplifiers, and receivers. So these are the different components used in the microwave system, which having the transmitter and the receiver. Between the transmitter and receiver, we are going to connect the channel as a medium. The channel having the two type of channel. One will be wired channel, another one will be wireless channel. So in the wired channel, we are using for optical cable, that is called wired channel, and coaxial cable also wired channel we are using. Similarly, in the wireless channel, we are using for very high frequency antennas. Okay. In this reflex klystron, gun, diode, traveling wave tube, and the magnetrons are used as the microwave sources. So as I told you, the transmitter is called as a source and the receiver is called as a destination. But the source, microwave source can be consist of any one of the components, the reflex crystal, gun, diode, traveling wave tube and the magnetrons are used as a microwave source. And isolator is provided for low attenuation for the forward direction and high attenuation for the reverse direction to avoid the reflected power. Here the term attenuation is called as some error, that is called a low signal strength will be reducing. So we have to increase the strength of the signal, so that we are using for isolator. And attenuator is used to provide attenuation for the higher power depends on the microwave applications. So attenuator is a component and isolator also is a component of microwave devices. The detector detects the microwave signal and the signal will be displayed in the oscilloscope or CRO, that is called the cathode ray oscilloscope. So some advantages of microwave system, it is because of their high operating frequencies. The microwave system can carry large quantities, large amount of information can be possible to transfer from one place to another place. And the high frequency means the short wavelength which require relatively small antennas. Microwave signals are more easily propagated around physical obstacles such as water and high mountains. Fewer repeaters are necessary for applications, and minimum crosstalk is exist between voice channels. Means crosstalk means there is no overlapping the signal from transmitter to receiver, and increase the reliability and the maintenance is very less in the we are using for microwave signals, and increase the bandwidth ability. So these are the some advantages of microwave system. Similarly, some few disadvantages of the microwave system is more difficult to analyze and design circuits at the microwave frequencies. It is difficult to implement the conventional circuit components like resistor, capacitor, inductors and so on at microwave frequencies, and the transmission time is more critical at the microwave frequencies because we are using very high frequency in the gigahertz range. So it is the time will be more critical to analyze the system. So some of the major applications of microwave system is called as telephone communication, radar, radio spectroscopy for material analysis, microwave landing system used to guide aircraft to land safety at the airport, diathermy machines are used in medicine for heating body muscles and tissues without hurting the skin. Microwave ovens are common appliance in kitchen. Microwave heating is also widely used in industry for variety of heating and melting applications. So these are the some of the applications of microwave systems. And next one, components of microwave system. The components, microwave components are very high frequency components, are designed to sections of using the sections of coaxial lines, waveguides, strips lines and microstrips lines. The maximum microwave components are made up of waveguides. Here the waveguides is a hollow metallic tube which is used to guide the microwave from one place to another place. So there are two types of microwave components. One will be active components, another one will be passive components. So the types of passive components in the microwave device: matched terminations, attenuator, phase shifter, directional control, coupler, T-junction, power divider, isolator and circulator. So these are the some of the passive components of microwave system. And some of the active components in that, there are two types of active components. One will be microwave vacuum tube devices, another one will be microwave solid state device. So in that, microwave vacuum tube device consists of two parts. One is the amplifier and another will be oscillator. In the amplifier there are two types. One will be two cavity crystal amplifier. It is used for LF, means low frequency applications. We are using this kind of amplifiers. And the traveling wave tube amplifiers, it is also called TWTA, which is used for high frequency applications of the microwave system. So similarly, the oscillator having the two types, which is used for low frequency, it is called as reflex klystron, and high frequency applications is called as magnetron. So these all are the different types of vacuum tubes devices in the microwave system. Similarly, we will discuss about the solid state devices. So in the solid state devices, we will be used for different components or different devices like gun diode, avalanche transit time devices, that is also called ATTD, and tunnel diodes, pin diodes, varactor diodes, microwave transistors, and these are the different types of microwave solid state devices which is used in the microwave applications. So now we will be discuss about the one of the passive component in the microwave system. It is also called as attenuator. So attenuators are a two-port microwave passive device. It is used to control power levels in a microwave system by partially absorbing the transmitted signal. Means here we are going to control the power level by using the attenuator from the transmitter to receiving port at the microwave system, in the microwave system. So in matched termination, the entire signal is absorbed. In attenuator, it is going to absorb the signal partially based on the application. So depends on the applications. It may be a communication, mobile communication, satellite communication, or radar communication applications. The attenuation is going to absorb the signal partially based on the applications. Attenuation, this is the diagrammatically representation in the attenuator device. It is a two-port network as well as it is a reciprocal device. That means any one of the port can be used as the input and output. So as I told you earlier, attenuator is a two-port network. So one port as a input port, another port it acts as a output port. So this is the diagram representation for input signal for port 1 and output signal for port 2 for the attenuator. So input signal is applied to the input of the attenuator. Some of the power can be absorbed by the attenuator, and the output side will get the controlled power. So we are giving the input signal at the attenuator in port 1, and in port 2 we will get the output signal with the some of the power can be absorbed, means controlling the power at the output of the attenuator. So there are different types of attenuator we are using in the microwave device. It is fixed type attenuator and precision type variable attenuators. So in the fixed type there are two types. One will be a coaxial line attenuator, another will be waveguide attenuator. In the waveguide attenuator we are using fixed waveguide attenuator and variable waveguide attenuators. So these are the different types of attenuators used in the microwave system. In the coaxial line attenuator, now we will be discuss about the coaxial line attenuator. It is a fixed type attenuator. So the diagram is representing for the construction of the coaxial line attenuator is having two conductors. One will be outer conductor, another one will be inner conductors. So the diagram, its a top layer is called as coaxial cable, and the middle of the material is used for lossy material, that is called resistive film material. And in this coaxial cable, we are going to place one lossy material in the form of thin resistive film in the center of the inner conductor. As I told you, in the middle part of the coaxial attenuator, we are using lossy material. And by using this lossy material, whatever microwave power is flowing through this cable, some of the energy is absorbed by the lossy material. This can be provided the fixed attenuation to the incoming signal, and the attenuation mean is loss. We know that the loss means we should not able to reduce the power. The power should be high at the transmitter and the receiving side of the microwave system. Here the type of the lossy material we are using for aqueduct sand. Aqueduct sand means it is a fixed one, it can be produced the fixed amount of attenuation. And next one is the fixed type waveguide attenuator. In this type of waveguide consists of a thin dielectric strip coated with the resistive film like our coaxial cable. So as I told you that in the previous coaxial type alternator. We in the outer layer we are using for coaxial cable. So similarly we will be using this waveguide alternator also in the coaxial cable. Here we are going to place this dielectric strip at the center of the waveguide. Means it is parallel to the E max, means the electric field, maximum electric field of the device. So it means the electric field comes towards upside, means it is perpendicular, means in the indicating the diagram is indicating the rose color arrow mark is representing for electric field in the upside, and this strip is also placed parallel to the electric field. Means the strip it is represented in the green color is parallel to the electric field, and it can absorb minimum amount of incoming signal. If it is perpendicular to electric field, it cannot absorb the required amount of attenuation. So this dielectric strip is placed parallel to the maximum electric field coming towards it. So here we are using for fixed type of waveguide, which is used for dielectric strip is parallel to the electric field. So the electric field and the dielectric material, so which is dielectric strip, it is connected in the waveguide alternator. The electric field is passing through this resistive film. It can induce current. So the current will be produced due to the electric field passing through the resistive film. So this resistive film can produce some heat, means the temperature can be produced in the resistive film. By this way we can introduce the attenuation, means the loss of the signal can be introduced. So induced current on the resistive film due to the incident wave results in power dissipation in the form of heat, that is attenuation of the microwave energy. So this is one of the type of microwave device. It is called as waveguide attenuator. So next we will be discuss about the microwave circulator. So it is also one of the microwave device. So it is a multi-port microwave passive device. So means it is having 3 port, 4 port, more than 2 port is called as multi-port. Okay, so maybe 2 port and 3 port. If we know that in the S parameter, 2 port network is representing the matrix S11, S12, S21, S22. There are the S matrix. In multi-port network we will be used more than 2, means 3 port network means will be represented as the S parameter is called as S11, S12, S13, S21, S22, S23, S31, S32, S33. So this is called as multi-port microwave device. In case of the multi-port network for 4 port network, means it is represented for the S matrix is S11, S12, S13, S14 and S21, S22, S23, S24 and S25. Sorry, S31, S32, S33, S34, and in the last port, that is called the 4th port is S41, S42, S43, S44. So these all are the multi-port microwave device. Okay, it is a non-reciprocal device. It means that the device allows the transmission in only one directions. There is no transmission in the opposite direction. It is called as non-reciprocal. The meaning of the non-reciprocal means here we are giving only one input, means another port having the output. Clear? So in this circulator, the wave can be traveled from one port to next immediate port in only one direction. So as I told you, for example, for port circulator, if I am giving input is the first port, means the next immediate port is the second port. So I will get the output from the second port. Okay, means that is called only one direction. I will get the output. Okay, if I am giving input to the second port, I will get the output at next immediate port 3. Similarly, if I am giving the input at port 3, then I will get the next immediate port is port 4 is the output port. Similarly, if I am giving the input is port 4, then I will get the output is the next immediate port 1. So this is the one directional only when we get the output in the circulator device. So this is the diagrammatical representation of the 4-port circulator. If I am giving to the input as the first port, as I told you earlier, the first port, if I am giving the input, then I will get the output in only port 2 only. I will not get output at port 3 and port 4. So port 2 is called as next immediate port. Clear? And if I am giving the input as second port, so as I told you earlier, port 2, if the input means next immediate port is called as port 3. So I can get the output is third port. Okay, I will not get the output from port 4 and port 1. Clear? Similarly, the input is given to third port, then I will get the output is port 4 only. 1 and 2 I will not get any output. So these are some types of circulators. So in general there are 3 types: 3-port circulator, 4-port circulator and microstrip circulator. So these are the different types of circulators used in the microwave passive device. So it is the diagram for 3-port circulator. Here it is 1 is representing for port 1, 2 is representing for port 2, 3 is representing for port 3, and it is the constructions of the 3-port circulator having the 120-degree phase shift for each port. Port 1 and port 2, the angle between port 2 and port 2 is called as 120 degrees. Similarly, the angle between port 2 and port 3 is called as 120 degrees. Similarly, the angle between port 3 and port 1 is called as 120 degrees. In the middle part of the 3-port circulator, the device is connected as a ferrite. The ferrite device which is used to control the input to the output. Okay, means if I am giving input in port 1, I will get the output at port 2 by using this ferrite device. Okay, I will not get the output at port 3 because I am giving the input is port 1, next immediate port is port 2. Similarly, if I am giving the input at port 2, means the next immediate port is port 3, I will get the output. Okay. So in 3-port circulator is constructed in 2 ways. One is by using 120 degree H plane waveguide. So the here H is indicating for H plane waveguide. In another method, strip line symmetrical Y junction with the central ferrite post. Clear? Means the central ferrite post is means the ferrite is the component which is connected at the center of the circulator in 3-port device. So in both cases of H plane waveguide and strip line symmetrical junction, means both the types we are going to use for ferrite is the device. In this first method, we have to ensure that the separation between the ports should be 120 degree. I told you as earlier, port between the port means port 1 and port 2 should be having 120 degree phase shift. Similarly, port 2 and port 3 similar 120 degree, and port 3 and port 1 is called the 120 degree separation. The characteristics of the ferrite are used to achieve the non-reciprocity between the ports. Depending on the polarization of the incident wave at the direction of the magnetic field, the microwave signal can travel from one port to another port. Means the signal will be travel from first to another port. Ferrite is giving minimum or very small attenuation for the clockwise polarization. So here again we are using only clockwise directions for the signal transfer. We have to give incident wave, that is transmitting wave, with the clockwise circularly polarized. At that time, ferrite can allow the signal to the second port. Means here we are giving input as the first port, and the ferrite can be allow the signal to the second port, not in third and the fourth. Okay, if the same signal can be reflected towards this first port, it is reflecting in the anti-clockwise ferrite is having the property to absorb anti-clockwise circularly polarized wave. Okay, so here as I told you earlier, the signal will be in the first port, then output will be in the second port. Okay, because of the ferrite can be using for clockwise polarized wave. If I am going to give the input at second port, the output is get from the third port. Okay, as I told you earlier, and depending on the polarization, the incident wave and the direction of the H, the microwave signal travels from port 1 to next immediate port. So S parameter of the 3-port circulator. So perfectly matched lossless non-reciprocal 3-port circulator. The S matrix for S 3-port circulator is given by S is equal to S11, S12, S13. These three for port 1, and S21, S22, S3 for port 2, S31, S32, S33 for port 3. Okay, for perfectly matched conditions, then S11 equal to S22 equal to S33 equal to 0. Then the signal flow will be S13 equal to S21 equal to S32 equal to 1. So substitute the above values into S matrix. Here I given in the matrix. So diagonal matrix are S11, S22, S33 are equal to 0, and remaining will be S13, S21 and S32 are represented in as value 1. Okay. Now we will discuss about the parameters of the circulators. So circulator having is a multi-port passive device. Okay. So parameters, the insertion loss of the circulator is less than decibel. Isolation should be 32 to 40 decibel, and VSWR is less than 1.5, that is voltage standing wave ratio is less than 1.5. So these are the parameters of the circulator. So thank you for your kind valuable information.